Today I have connected bridge rectifier, a full wave bridge rectifier. So for that we need 4 diodes, 1N4007 diodes. We have taken 4, 1, 2, 3 and 4, and we have to use one resistor, which is a 1 kilo ohm resistor. Okay, and now we have connected as per the connections given in the circuit diagram. Here you can see the negative part of the diode is being connected to the positive of the next diode, then negative of the other diode is connected to the negative of the third diode, and positive is again connected to the negative of the fourth diode. So it connects, it looks like a bridge, and there is a 1 kilo ohm 1 kilo ohm resistor which is being placed across the diodes, where you can see one end of the resistor is placed where the negative and negative of the diode meets, and the other end is being placed where the positive and positive of the other two diodes meets. Now we need to give the input waveform. For input waveform we use a frequency generator which provides you with the sine wave, where I have given a frequency value of 50 Hertz and the amplitude is given as 12 volt peak to peak VPP. Now when you connect, you can connect the input voltage with the positive wire connected to the diode section where the positive and negative meets, and the negative is being connected just opposite to that where the negative and positive meets. So the positive and negative is being connected diagonally. Now in order to find the output waveform for the bridge rectifier, you can connect from the CRO. We have the CRO over here. From there you can connect the positive of the CRO to this point where the two negatives of the diodes connect, and the negative is being connected to the point where two positives of the diodes are being connected. So when you connect this, we are going to view the output of the bridge rectifier. So if I stop this and if I adjust, here you can see that this is the output waveform of a bridge rectifier. Now this is actual working of the bridge rectifier is that if you want, this circuit is actually without the capacitor, which means without the filter. So if you are using a capacitor, so that you'll be able to see that these ripples will be changed. So let's see what happens. So here I'm using a 100 microfarad capacitor. We'll place the positive, the long lead, we call it as the capacitor's positive lead, and the short one is the negative. So we can place the capacitor across the resistor. So we have placed the capacitor, 100 microfarad capacitor, across the resistor. If you could stop this and see. Now you can see that compared to the bridge rectifier output, the ripples are almost less when compared to the previous output. Now if you want to change this ripples, these sort of ripples into a straight DC output, you have to vary the capacitor value. So what I'm going to do is that I'm going to place a capacitor value which is more than 100 microfarad. So I have 470 microfarad with me. So I'm going to place, instead of 100 microfarad, I'm going to place this. So we can change, you can see the output. If we place the 470 microfarad, then you can see it's almost the DC output you will be getting. So this is how we can make use of the filter or the capacitor value if we increase the capacitor value, so that we will get the straight DC output.